Hi, we are from Group 5. So today we are going to present Lab 9, rolling disc on inclined plane. Our group consists of 5 members, Arya, Shafira, me, Kencana, Auni and Sophia. So here are the table of content. Now I'm going to present the introduction of the experiment. Rolling disc on inclined plane. So the TM611 units allows you to determine mass moment of inertia through two types of tests, which is the rolling test on an inclined plane and also the pendulum studies with an actual pendulum. So the inclination of the inclined plane is set through height adjustment and measured with an angulometer in the rolling experiments. The track is rolled down by disc. The mass moment of inertia is calculated after measuring the time and acceleration distance. For the pendulum experiments, the disc is rotated into the pendulum. The disc is deflected and rotates in pendulum motion. The mass moment of inertia is calculated using the recorded time while swinging, the mass and also the distance to the center of the rotor. So in this experiment involved two theories, and that is free falling and motion of inertia. So for free fall, it was introduced by Galileo Galilei. He claims that heavy bodies do indeed fall in that manner, and that if a vacuum could be created, any two falling bodies would travel the same distance in the same amount of time. He makes predictions about balls rolling down an inclined plane based on this idea, and then presents several inclined plane experiments that support his theory. So by splitting the gravitational force acting on the rolling balls into two vectors, one perpendicular to the inclined plane and the other parallel to it, we can establish Galileo's hypothesis using Newton's principles. Galileo formulated the equation for a falling body or an item moving with uniform acceleration based on his experiment. As a result, all bodies, regardless of their shape, nature or weight, fall at the same rate. Free fall is a phrase for this type of motion. The acceleration of free fall is measured in g equals to 9.8 meter per second squared. A free falling body's final speed is only determined by the height to which it has fallen. Now we move on to the motion of inertia. A feature of the body known as inertia is responsible for all body's behavior in maintaining a state of rest or evenly straight line movement. As a result, we call this behavior the law of inertia. The law of inertia states that every mass point remains at rest or in a state of uniform movement on a straight path as long as no forces are acting on it, according to Newton. So when a disc is allowed to roll down an inclined plane, it accelerates in a consistent manner. The quantity of acceleration is determined by the angle of inclination and the moment of inertia, which serve as a brake. Depending on the mass's distance from the rotating axis, the body can have varying moments of inertia. The mass moment of inertia for a variety of bodies are detailed in the literature. The moment of inertia for a disc, like in our experiment, is as follows, and also the acceleration is calculated as follows. So that's all from me. Thank you.
I am Aina Sofia Batizandin, MH19038, and I will explain the objective of this experiment. There are some objectives that need to be enclosed during this experiment, which is the first one is to understand the relationship of mass moment of inertia, angular acceleration, and angular velocity of a disc rolling down an inclined plane. The second one is to calculate the mass moment of inertia by pendulum experiment. And the last objective of the experiment is to understand the law of falling bodies on an inclined plane.
Hi, my name is Auni Alamiti Zulkifli. My matrix number is MH19024. Today I would like to share the experiment procedure for Lab 9. So, the equipment consists of TM61 rolling disc on an inclined plate, which is for test 1. I will use golf ball as disc 1, represent large disc with diameter 55mm and the mass is 130 grams. And for the disc 2, I will use toy ball, represent for small disc with diameter 37mm with mass is 45 grams. For inclined plane, I will use cardboards. For the angle inclinations, I will use 7 books, represent for 7 angles. I will use smartphone stopwatch to measure the times and the ruler to measure desired distance. Next, this is our experiment setup at home. So, for this one, we set up these experiments basically at home. So, first, the inclined plane cardboard has set into a desired angle of inclinations. Desired distance, which is our cardboard, is at 150mm, was measured by using a ruler, and the stopwatch has been ready. The disc 1 and 2 placed at 0 positions on the track, and the midpoint of the rotational axis is marked. The disc 1 and 2 also positions in the center. The stopwatch started Once the J was let go at the end distance of the disc and stop the records, make sure the watch is on stop when the midpoint has reached the measured mark. Repeat the procedure for 3 times in order to minimize measurements error. The calculation of mean value for each series of experiment has been calculated in Table 1 and Table 2, and also for Table 3, test case.
Okay, I'm Shafira Aiza, MH1029. I'm going to cover the next part of this experiment, which is the result. Okay, this is the result for table 1, which is the result for the roll time for a distance at 850 meters. This result consists of two data, which is for the large disc and also for the small disc. So we have 7 angle of inclination, and each large and small disc, we have to repeat the experiment for 3 times to get the average reading. And we noticed that for the large disc and also the small disc, the average reading for both are decreasing from 1 to 7 angle of inclination. So for table 2 and table 3, we have to calculate the acceleration, calculated time, and also the deviation for both large and small discs. These are the example of the calculation that we made for the angle of inclination for 1 degree. So for accelerate, we have to calculate for the mass of moment of inertia J to put it in the acceleration formula. And then we have to calculate the calculated time and also the deviation. We have to repeat this for 7 angle of inclination. And this one is the table result for the small disc. Like we have to repeat the same thing for the large and small disc. Both will present the different type of data because of small and large disc has different mass and also different radius. And this is the example for calculation for the small disc. For the test 2 pendulum support, we have to calculate the average reading for the both large disc and also small disc, and we have to calculate the angular velocity and moment of inertia. Lastly, this is the example of calculation that we made for the test 2. We have to find the period, which is the average reading that we got before, and the frequency, and then use the frequency to apply in the angular velocity formula. And lastly, we calculate for the moment of inertia. That's all from me. Thank you.
Hello everyone, my name is Arya Anak Perempuan Ehput. My student ID MH19019. Today I will continue our presentation with the discussion part. So the answer for question 1 is the angle of inclination can be adjusted by turning the height adjuster spindle. In this experiment, we are using our own creativity, which is taking the book to increase the angle of inclination. For the question 2 is what is the purpose of angulometer? So the answer is the purpose of angulometer is to measure the angle of inclination. Next, question 3. Answer is the alternative method to measure the angle of inclination is using the protractor. Next, question 4. The answer is to make a precise alignment for this experiment is make sure that the inclined plane have a flat surface to avoid the error when rolling the rolling ball on the plane. Next, for the question 5, the answer is the angle higher than 7 degrees cannot be used for this experiment because of the rolling disc will slip at the higher acceleration and it is difficult to collect the data. Finally, it will affect the result of the experiment. Next, the answer for question 6 is based on Galileo theory for free fall, the object fall with the same acceleration regardless of their mass or size when absent of air resistance. Next, for the question 7, the main factor that causes a free-falling body is the gravitational acceleration. Question 8, the answer is when the angle of inclination increases, the acceleration of the rolling disc also increases. For the question 9, according to the Newton's first law of motion inertia, inertia is the position that the object stays at rest and the object in motion stays in motion with the same speed and same direction without force acting on it. Question 10, the answer is to ensure the collected data have the high accuracy. For the question 11, this is the free body diagram of the disc roll on the inclined plane. Next, question 12, the answer is deviation, also known as measurement error. It will occur between calculation and measured value due to the human error while collecting the data. So the last question is suggest the improvement of this experiment. So the answer is the experiment should be repeated at least 3 times or more to avoid the human error by collecting the data. In conclusion, the relationship between angle of inclination and the acceleration of the rolling disc is directly proportional. The acceleration of rolling disc can be determined by using the mass moment of inertia and basic kinematic equation. In this experiment, we also know that the angular acceleration is constant and the angular velocity increases when the ball moves down. That's all for me. Thank you.